In this question, let's create a partial loan repayment schedule. We're going to show the details of the first 2 payments and the last 2 payments. In our example, we're going to start with a loan of $750,000 that has bi-weekly payments at a rate of 4.5% compounded semi-annually, and let's assume that the term is 25 years. After we've constructed the partial loan repayment schedule, we're going to go ahead and try to calculate the total amount of interest paid as well. What we want to do here is start setting up the table we're going to use for our loan repayment schedule. I've gone ahead and I've marked the first 3 time steps we're going to look at, which are 0, 1, and 2, but we need to figure out what the last 2 payments are going to be as well. Since we have bi-weekly payments happening over the span of 25 years, what we can do is we can take 26 and multiply that by 25, and we know that n is equal to 650. So let's take a look at rows 649 as well as 650. In order for us to get there, though, we are going to need the payment size, since that's not given to us in the question. So let's go ahead and utilize the calculator. We're going to input a couple parameters here to figure out what that payment size is going to be. And I am going to assume here that we are working in end mode. So let's see, we have bi-weekly payments. And yeah, we just need to calculate our payment size. Let's begin by programming in our 650 for n. We have 4.5 as our interest rate. We can go into the submenu and start programming in bi-weekly payments, and then we're going to scroll down and get semi-annual compounding in. We know that we are going to receive an initial amount of $750,000, so let's put that in as a positive value for our PV, and then 0 in for our future value. We should now be able to compute the payment size. And rounding up the 2 decimal places, we're going to get $1,913.96. Now we can start filling in some of the rows here inside of our repayment schedule. Of course, we know in row 0, we just begin with our principal amount of $750,000. In row number 1, we are going to apply a payment of $1,913.96, and we need to figure out how much of that is going to be the interest and how much of that is going to be the principal. In order to do that, we are going to need the value for I2, and that's because the payment frequency is bi-weekly, but our compounding frequency is actually semi-annually. So calculating I2, we're going to start with our open bracket. We're going to go 1 plus our current rate, which is 4.5% compounded semi-annually. Let's close that bracket and raise this to the power of open bracket 2 over 26. Close that bracket and subtract 1. This should be the value of I2, so I'm going to go ahead and I'm going to store that under number 9 so that we can recall it later. Next, in order to move forward along row number 1, we need to take our principal balance of $750,000 and we need to multiply that by I2. Doing that gives interest of $1,284.79. If we subtract this from our payment size of $1,913.96, we should get the principal portion of this particular payment. Which is $629.17. Subtracting this amount from our original balance should yield our new balance. And doing that gives us around $749,370.83. This means we can now move into row number 2, or the second payment of $1913.96. In order to determine the interest portion of this particular payment, let's take the $749 that we have currently, let's multiply that by I2. That's going to give us about $1,283.71. If we were to subtract this from the payment amount of $1913.96, we should get the principal portion of payment number 2. Which is around $630.25. And once again, if we subtract this value from the balance that we started with, which is our $749,370.83, that should give us our new and updated balance. That should take care of rows 1 and 2. What we'd like to do now is skip forward in time and try to ask the calculator what's happening during these last 2 payment periods. And I realize now that I am going to need an extra bit of information. I am going to need the future balance at row 648. In order to get that value, I'm going to have to program in this equal-sized payment of $1,913.96. I'm going to make that a negative here because we are paying the bank. And what we're going to do is we're going to update our value for n to 648. All of our other parameters should be able to stay the same, and I should now be able to compute the future value after this many payment periods. The calculator here gives a balance of $3,812.36. So what I'm going to do on the calculator is I'm just going to turn that into a positive value, and I'm going to go ahead, I'm going to multiply this by I2. That's going to give me the interest portion that we need to charge at row 649. So we need about $6.53 in interest here. If we were to take that value and subtract it from our $1913.96, we should get the principal portion going to pay down that loan, which is $1907.43. And then, of course, if we take this value and subtract it from the balance owing, which is $3812.36, we should get the new updated balance, which is $1,904.93. Since $1904.93 is actually less than our payment amount, this means that our last payment is going to be this dollar amount plus whatever interest is actually owed on the loan at the end of this particular payment period. So in other words, we know that at the end of this last payment, we should have a zero balance. And the principal amount that we should be paying in this last payment period should be $1904.93. If we take this $1904.93 and we multiply it by I2, we can figure out how much interest we need to charge during this particular payment period, which is $3.26. To figure out the size of the last payment, let's take our $3.26 and add it to the principal balance that we have owing right now, which is $1904.93. And that tells us the last payment has size $1,908.19. So it's just a little bit smaller than that payment size we calculated before we started the schedule. The last thing we want to do to finish off this question is try to determine the total amount of interest that has been paid. And typically we do that by adding up all of our payments and subtracting the principal amount. So in our case, we would like to add up all the payments. We made 649 equal-sized payments of $1913.96, and we had one partial payment of $1908.19. If we add up all of these payments and then subtract the principal amount of $750,000, this should tell us how much interest that we've actually paid over the term of this particular loan. Simplifying this expression, we get that the interest that was charged should be around $494,068.23.